Hello everyone, this is my second video in this scattering series. We have done some numericals in the previous class on the scattering in the chapter, so we will be continuing that. So, I think this will be question number 4. The question number 4 is, in a scattering experiment, the potential is spherically symmetric. The potential is spherically symmetric. Potentially spherical symmetric, and the and the particles are scattered and the particles are scattered at such energy at such energy that only s only s and only s and p waves need to be considered. Only s and p waves need to be considered. Okay, so the question is, so that the differential cross section so that the cross section differential cross section sigma theta can be written as can be written in the form sigma theta is equal to a plus b cos theta plus c cos square theta. Okay. The second question is, what are the values of ABC? What are the values of ABC in terms of phase shifts? In terms of phase shifts. Okay. And the final question is, what is the value of what is the value of total cross section in terms of ABC? Is the value of total cross section in terms of ABC. In a scattering experiment, the potential is spherical symmetric. The particles are scattered at such energy that S and P waves need to be considered. So that the differential cross section sigma theta can be written in the form this. Okay, we have to show this. What are the values of ABC in terms of phase shifts? What is the value of total cross section in terms of ABC? Okay. Alright, so let's start this question. We have to find sigma theta. So first of all, to find sigma theta, what we need? We need scattering amplitude, right? We always need scattering amplitude. So because sigma theta is what? Sigma theta is actually what? F of theta square, correct? So we need f of theta. That is, this is a scattering amplitude. We need scattering amplitude. So f of theta is what? What is f of theta? We had written in the previous class the formula L0 to infinity 12 plus 1 PL cos theta e to the power I delta L sin delta L, isn't it? This is the formula, right? This is the formula for scattering amplitude, correct? Okay. So here, what is the question? Only S and P waves are considered. So what is S and P wave? For S and P wave, if you remember, is for S wave, L is equal to L has a value that is 0. For P wave, the value of L is 1. Okay, so we'll put it here. So 1 by K summation L 0 to infinity, put 0 here. So it will be P0 cos theta. Okay, P0 cos theta is 1. Okay, this is 1. So 1 into e to the power I delta 0, e to the power I delta 0 sine delta 0. Okay, plus plus I'll put 1 now. So 2 into 1 plus 1, that is 3. 3. P1 cos theta is, this is legendary polynomial, so that will be P1 of x is x. So P1 cos theta should be cos theta. Okay, so this is cos theta e to the power I delta 3 sine delta 3. Okay, so this is the expression. Alright. Okay, now we have to square it. We'll get our sigma theta. Sigma theta is scattering amplitude whole square. So 1 by k square. This is the whole square of this one. Okay, the whole square of this whole term. Okay, so I e to the power 2I delta 0 sine square delta 0 plus 9 cos square theta e to the power 2I delta 3 sine square delta 3 plus 2 e to the power I delta 0 sine delta 0 into 3 cos theta e to the power I delta 3 sine delta 3. So this is the whole square term. Okay, alright. Yeah. So what can we do here is, um, what can we do here is we can expand. We have to expand this. We have to expand this. We do got 2 I delta 0. We have to kind of expand this. If I expand it, like, it will be cos 2 delta 0 plus I sine 2 delta 0. Okay, so sine square delta 0, um, plus, again this one also I have to expand. So theta. So cos 2 delta 3 plus I sine 2 delta 3 into sine square delta 3 into sine square delta 3 plus this one plus 2 e to the power I delta 0 plus delta 3, then sine delta 0 del sine delta 3 into cos theta. This 3 will multiply to give you 6. So this is the term. This is f of theta whole square. Okay. So what do we need? We need, if you remember the question, sigma theta is given as a plus b cos theta plus c cos square theta. So we need to kind of get that from a plus b cos theta plus c cos square theta. We need to find this way. So let's see. Let's check. Let's. We also have to keep multiplying this. Okay. I have to multiply these terms. Okay, I have made a mistake. This is a is equal to 1 now. This is 1. This is 1. This is 3, but this is 1. I'm making mistakes here. This is 1. 1. Complete mistake. Okay. So what will I do here? I will have to multiply everything now. So 1 by k square. Here cos 2 delta 0 into sine square delta 0 plus I sine 2 delta 0 into sine square delta 0 plus 9 cos square theta into cos 2 delta 1 plus 9 into 9 cos square theta into sine 2 delta 1. Okay. Then yes, there is another term also sine square delta 1, so sine square delta 1. So you have to do it this way, okay? There is no other way. You have to expand it. After expansion, actually, after expansion, you will get something like 1 by k square. Okay, sine square delta 0. I'm directly writing the answer. You have to expand it yourself. 6 sine delta 0 sine delta 1 cos delta 0 minus delta 1. Okay, cos theta plus 9 sine square delta 1. Okay, cos square theta. This is what you will get. So we need in what form sigma should be a plus b cos theta plus c cos square theta, right? C cos theta. So C and this will be a b cos theta. So this is your b, c cos square theta. So this is cos theta. So this is your c. So I will write it here. So a is actually sine square delta 0. Okay. By k square is also there. By k square is outside. So by k square. Now b is what? B is this one. 6 sine delta 0 sine delta 1 cos delta 0 minus delta 1 whole divided by k square, and your c is how much? This one should be c. So 9 sine square. So this is your, these are the values of the ABC that we are asked. Okay, alright. Now what is the next question? What is the value of total cross section in terms of AB and C? So again we are asked the total cross section here. Okay. This is the total cross section. This is this one, right? This is sigma is the total cross section. So that is the answer. Okay. So yeah, this is the way to do it. You have to kind of expand the things a bit. It's just not directly you can just do it. You have to expand this type of questions. You have to expand the exponential terms and all. Okay. Okay. Let's write the next question. That'll be question number 5, I think. Question number 4 is the question number 5. Question number 5, that is saying consider scattering by a central potential. Consider scattering by a central potential by the methods of by the methods of partial wave analysis, partial wave analysis. Okay, by the methods of partial wave analysis and Born partial wave analysis and Born approximation. Okay? And Born approximation. Okay, where delta L is small, when delta L is small, when delta L is small, prove that the expression prove that the expressions prove that the expressions for scattering amplitude prove that the expressions for scattering amplitude in the in the two methods in the two methods are equivalent. Okay, are equivalent given What is given here? Given summation I 12 plus 1 PL cos theta, okay, J square L K R, okay, is equal to sin QR divided by QR. You have to prove it. Like where Q is equal to 2K sin theta by 2. Again, this is kind of a long type of question, but we have to do it anyway. Consider scattering by central potential by methods of partial wave analysis and first Born approximation. Okay. So when delta L is small, prove that the expressions for scattering amplitude in two methods are equivalent. So we have to do it. So let's see. We have to prove this. Okay. This is what is JLKR. This is a Bessel function. Okay. So legendary polynomial Bessel function. These things need to be really clear in your mind before going into this chapter. Okay. Otherwise, I will. We'll have a class in which we will discuss about Bessel function and legendary polynomial. Okay, no problem. Because those things are really advanced things and we have to do them. Those things are usually asked in the interview, so I cannot just skip them. We have to do them. Okay. So let's start this question. Okay. First of all, again, what is asked? Uh, Look at the expression for scattering amplitude. So scattering amplitude is this one. Okay. So see, there is another expression for scattering amplitude in the case of partial wave analysis. Okay, we have to write it. Write down in the case of partial wave analysis. In the case of partial wave analysis, okay, the scattering amplitude is what? The scattering amplitude. Okay, scattering amplitude is what? F of theta is equal to what? 1 by 2 I k summation L 12 plus 1 e to the power 2 I delta L minus 1 PL cos theta. Okay, so this is the expression for partial wave analysis in case of like sorry, expression for scattering amplitude in case of partial wave analysis. Okay, so this is kind of different from what we have done. Okay, um, so here when delta is very small, what happens is when delta is very small, so 2 e to the power 2 I delta L minus 1, this kind of becomes equal to 2 I delta L. Okay, 2 I delta this exponent power becomes this 2 I delta L. So in case place of this, I can directly put this 2 I delta L. Okay, so 2 I k summation L 12 plus 1 2 I delta L PL, what PL cos theta, right? So 2I got cancelled. Okay, it can come out and get cancelled, no problem. So the expression I'm getting is 1 by k summation L 12 plus 1 delta L PL cos theta. Okay. Okay. Now the thing is, we have to kind of put the value delta L. So there is another value delta L that we will put it here. So after putting the value of delta L, so f of theta will become minus 2 mu by h cut square summation L 12 plus 1 PL cos theta, okay, integration 0 to infinity VR JL square KR R square dr. So this is the expression, okay, I will get. This is the, you have to study this chapter, then only you will know. So, what is given in the question given is summation 12 plus 1 PL cos theta. We have to extensively do this question. JLPR and with this chapter specifically. Sin QR by R QR. So in place of this, like this, in place of this, I have to put sin QR by QR, which I will put in the inside the integration. So this becomes f of theta equals to minus 2 mu by h cut square. This whole thing goes into the integration 0 to infinity sin QR by QR. What is left there? VR is left. Also this R square is left, R square dr. Okay, so this is what you will get at the end. So this is the expression for scattering amplitude. Okay, so if you see, I will cancel this R and this take out this Q. This will be minus 2 mu by h cut square Q, 0 to infinity. If you remember R, VR, sin QR, this is the expression we used yesterday in a question. Like in the previous class, we used it. So this is called your scattering amplitude for central potential. Okay, scattering amplitude. This is scattering amplitude for central potential. All right. This is a very important relation which will be used, and also under Born approximation, this comes under Born approximation. Okay. So please remember this. Practice more questions on this, you will understand. No problem. Let's do one question exactly on this formula, then you will understand. Like where potential will be given, this VR will be given, you just have to put it and you have to solve the integration. Okay, so this will be next will be your question number 6. Your question number 6 here. Okay. Now the question number 6 comes. Evaluate the scattering amplitude. Okay, find scattering amplitude f theta. Just the application of the previous one. Evaluate the scattering amplitude in the Born approximation. In the Born approximation for scattering by Yukawa potential. Okay, scattering by the Yukawa potential. There is a thing called Yukawa potential. You must have studied in nuclear physics. Okay, Yukawa potential VR is equal to V naught exponential minus alpha by R. This is the expression for Yukawa potential. Okay, this is the expression for Yukawa potential. So where V naught and alpha are constants. Okay, yeah, you have to also show that the question still is there. Also show that sigma theta peaks sigma theta peaks in the forward direction. Sigma theta peaks in the forward direction. Sigma theta peaks in the forward direction. Theta is equal to 0 except at 0 energy and decreases monotonically as theta varies from 0 to pi. Okay, so that sigma theta peaks in the forward direction, theta 0 except at 0 energy, and decreases monotonically as theta varies from 0 to pi. So this is the expression for Yukawa potential. We have to use it to get scattering amplitude. Okay, so we just have to put the value of VR here. So let's do it. So what is the potential? Scattering amplitude. F of theta is equal to minus 2 mu by h cut square q, 0 to infinity r Vr sine QR dr, right? So let's put in place of Vr what is there? Minus 2 mu by h cut square 0 to infinity r. What is it? What is it given? V naught exponential minus alpha r by r, right? Sine QR dr. How to solve it? How to solve this? Actually, this is not. I'm making a mistake. Sorry. This is. It's like this actually. E to the minus alpha r by r. Okay. So let me just let's write it properly. E to the power minus alpha r by r. So that r will be cancelled. Okay. So r got cancelled here. So v naught goes out. So minus 2 mu v naught by h cut square q, 0 to infinity e to the power minus alpha sine q. I had told you a formula yesterday, like this formula, exactly this formula. If you remember, what is the formula? Can you tell me? Integration of 0 to infinity e to the power minus alpha sine q r. It has a direct formula, and the formula is what? Q by the integration value is q by q square plus alpha square. Just remember it, okay? You don't need to solve it. If you solve it, there will be a long process. So minus 2 mu v naught by h cut square q. Better to remember this kind of integrations to be solving these questions quickly. Okay? Quickly get cancelled. So what is the expression? Minus 2 mu v naught divided by h cut square. Okay, q square plus alpha square. Right? Yeah. Okay. What is your q? Q is your 2k sine theta by 2. Okay. So let's put it here. So minus 2 mu v naught divided by h cut square alpha square plus 4k square sine square theta by 2. Okay. So this is the expression I am getting for f of theta. Okay. What? Okay. I can also. There is this question also, so that sigma theta peaks in the forward direction, that is sigma theta 0. Okay, so I have to kind of get the value of sigma theta. So sigma theta is what? The square of scattering amplitude, right? So if I put it here, so 4 mu square v naught square divided by h cut fourth alpha square plus 4k square sine square theta by 2 whole square. Okay, so this is the expression for sigma theta. All right, but the thing is, what is the question? Question says sigma theta peaks in the forward direction, that is theta equal to 0. Okay, let's put theta is equal to 0. If I put theta is equal to 0, so I will get sigma 0 is equal to 4 mu square v naught square divided by h cut fourth alpha square. This whole term becomes 0 square. So 4 mu square v naught square divided by alpha h cut alpha whole fourth, right? So this is what I am getting, right? Okay, so this is the peak value. It's saying this is the peak value because this peaks in the forward direction, that theta is equal to 0. Okay, so this is the peak value of sigma. The peak value of sigma. Okay, yeah. And it's also saying what? It's also saying it decreases monotonically as theta varies from 0 to pi. Okay, if I put theta as pi, what will happen? It will be the same thing, isn't it? If theta is equal to pi, I will get the same thing. Okay, no problem. I got the maximum value, so no problem. That will be the answer. Alright. Next question will be see, first of all, in this type of questions, first thing is we have to get the scattering amplitude, then we have to just square it. Okay, square it. Usually, the potential is given, VR is given. We just have to put the value of VR in f theta, that is minus 2 mu by h cut square q integration 0 to infinity r VR sine QR dr. So we just have to put the value of VR here. Usually this VR is in such a way that RR will be cancelled out. R will be cancelled out, and you will find the easy integration. And always remember 0 to infinity e to the minus alpha sine q or dr. This integration is what? Just remember q by q square plus alpha square. Okay, so this is the expression. Alright. Okay. Okay, let's move to the next question. This is called this is for central potential. Okay, there is another thing called a general potential also. Okay, we'll do that also. Okay, next question. Question number. What is the question number? It will be 7, right? Okay, question number 7. Question number 7. Using Born approximation, using Born approximations, calculate the differential, calculate the differential and total cross section, calculate the differential and total cross section for scattering of a particle, for scattering of a particle of mass m by the delta function potential, by the delta function, by the delta function potential Vr is equal to g sigma r, where g is a constant. Okay, where g is a constant. Okay. So your potential is given. This is a delta function potential because there is a delta function is 0. Okay. So how to solve this one? This one will be solved in a different way. Here the scattering amplitude that will be used is scattering amplitude. General potential will be used. This is called general potential. Scattering amplitude will be used f of theta is equal to minus mu by 2 pi h cut square integration exponential I q r v r dr. Okay, this is the expression for uh, scattering amplitude for a general potential. Okay, so VR, let's put the value of VR. Okay, minus, okay, 0 to infinity minus mu by 2 pi h cut square 0 to infinity e to the power I q r. VR is what? G into delta r dr. Okay, okay, see how to solve delta function integrations. Suppose this is f of x delta x dx. Okay, or suppose no, wait. Suppose f of x delta x minus a dx integration 0 to whatever infinity suppose, and we have to first equate this x minus a is equal to 0, so x is equal to a. So this, if this a is in between this limit 0 to infinity, then I will just put the value of a here in f of x. Okay, so the answer will be f of a. Okay, suppose the question is 0 to pi 0 to pi sine x, okay, delta x minus pi by 2 dx. This is the suppose the question of integration. Okay, so now I will equate this x minus pi by 2 is equal to 0. I will equate the inside part of delta. So x is equal to pi by 2. So this pi by 2 comes in between 0 to pi, isn't it? So what will I do? I will put pi by 2 in sin x. So that will be, the answer will be directly sin pi by 2. Okay? So that will be 1. If this does not fall inside this limit, then it will be 0. Answer will be 0. Suppose 0 to pi by 3, no, 0 to, yeah, 0 to pi by 3 sin x delta x minus pi by 2. So pi by 2, x is equal to pi by 2. Pi by 2 does not fall in between 0. Pi by 2 is what? 90 degree. 0 to, this is 0 to 60 degree. So this does not fall in between this. So the answer of this integration will be 0. Okay. So this is the integration using delta function potential. Okay. So here see delta r. So r minus something. What is that? 0 is equal to 0. So r is equal to 0. So r is equal to 0 falls in between 0 to infinity because 0 is there. So I will put 0 in f of x, that is e to the power iq1. G will come out. So minus mu g by 2 pi h cut square. I hope you understood. E to the power iq0. Okay. So e to the power iq0 is 1. The answer is what? So f of theta is equal to minus mu g by 2 pi h cut. Alright. So what is the question? Question is get differential. Okay, what is it? Differential scattering cross section. So that is sigma theta. Okay. Differential cross section d sigma by d theta. This is also equal to f of theta square. Okay. So mu square g square divided by 4 pi square h cut 4. What will be the total cross section? This is differential cross section. Differential scattering cross section. Total scattering cross section. Total scattering cross section. Total scattering cross section sigma is equal to integration. We know integrations d sigma d theta d omega. Right? D omega is again what? D sigma by d theta. D omega is sine theta d theta d phi. So this is your 0 to pi. This limit is for d theta. 0 to 2 pi. This limit is for d phi. So usually this answer is what? 4 pi into d sigma by d. Okay. So 4 pi into whatever we got, mu square g square divided by 4 pi square. Sorry. Yeah, 4 pi square h cut 4. My bad. Yeah, that's correct. So 4 pi, it will be cancelled. So only pi will remain in the denominator. So mu square g square divided by pi. So this is your answer for total scattering cross section. I hope you understood. Okay, one more question we'll do. This will be the last question for today. Hmm, Question number 8. This is the last question. Write down. For an attractive square well potential, for an attractive square well potential, VR is equal to minus V naught. So 0 R, this is the condition, and VR is equal to 0 when R is greater than R. Okay. So find the energy dependence. Find the energy dependence of the phase shift. Find the energy dependence of the phase shift delta 0 by Born approximation. By Born approximation. Hence, so that so that at high energies, at high energies, delta naught k tends to m r naught v naught divided by h cut square k, where k square is what? K square is a 2m by h cut square. This is the question. So here we have to show that delta naught k is equal to this much, and find the energy dependence of the phase shift delta naught. How to approach this question? How to approach this question? So we for this solve this question we have to know the phase shift for in one approximation. Phase shift, that is delta naught is equal to 2m k by h square v naught integration integration 0 to r naught j naught square. Again, this Bessel function is coming again and again, so we have to take a class of this Bessel function. Okay, so this is delta naught. Okay, this is delta naught, and what will you do now? Okay, what is the value of j naught kr? Do you know? J naught kr is actually sine kr by kr. Just put it there. So 2mk by h cut square v naught 0 to 1 naught sine square kr divided by k square r square r square. As I told you before, this thing will be such a way that these things will be cancelled out. So k square goes out. 2mk v naught by h cut square k square 0 to 1 naught. Only sine square remains inside. How to get the integration of a sine term, sine square term? We know 2m v naught by h cut square k. I just cancel out 0 to v naught. Okay, this can be written as 1 minus cos 2 kr whole divided by 2 dr, right? Yeah. So let's take 2 out. So m v naught 2 cancelled out. H cut square k. Integration of this one will be v minus sine 2 kr divided by 2k. And the limit will be 0 to v naught. Okay, let's put the value of v naught there. So m v naught divided by h cut square k, v naught minus sine. Okay, sorry. Yeah, this is r naught. This is r naught. What am I doing? This is r naught. Sorry, my bad. R naught. Okay, sine 2k r naught divided by 2k, and then minus 0 will be 0. So this will be the expression. If I take the LCM, m v naught divided by h cut square k, 2k r naught minus sine 2k r naught divided by 2k. Okay, so let's take this 2k out. So m v naught divided by h 2 h cut square k square 2k r naught minus sine 2k r naught, which will be the final expression for delta. Okay, so that will be the answer. Okay, at high energies, what happens is at high energies, k tends to infinity. Okay, so k tends to infinity. So what happens is uh, this term becomes 0. Okay, and we will get a final expression delta naught is equal to mv naught, the one that is in the question, r naught divided by h cut square k. So this will be the expression we will get at. Alright. Okay then. That will be it for this class. We'll be solving more questions. This will really help you for tough exams like TIFR or the advanced section of CSI Net. So we need to build a basic approach so that you'll be able to solve these questions. Okay, we did like 4 questions and they were really valuable questions. Okay, okay then. See you in the next class. Thank you.